Hi, this is a recording that I'm doing for Year 9 iGCSE Chemistry, the Stoichiometry exercise that I set in week 2. So what I'm going to do is I'm going to go through the examples for balancing chemical equations. The answers are on the screen as we speak, so you can pause this and have a look through the answers. And then what I will do is I will actually go through each and every single one of those examples as well. So pause this is the video if you want to have a look. There is a slight typo with the first one, but when I go through it and I will highlight it. The number of oxygens was 3 on the equation. This should have been a 3, and I tried to get that information out to you before the deadline was set, and I hope that information got to you. So there's just a slight one. This is actually, believe it or not, from an exam board as well. So I was very, very surprised to see that even the exam boards are getting things wrong on this one. What I'm going to do is I'm just going to go through the first one. So just for now, you might want to ignore the 2 that is written in red in front of the HCl. And what I've got is I've actually got this already pasted into Paint 3D. But I think what I'm going to do is I'm going to have to just start fresh from this one, so bear with me. Here we go. So I don't really want to have that big fat cross in the middle. There we go, that's much better. So Paint 3D, by the way, while I just get the settings right on this one, is actually a really useful program for you to use, particularly if you are having problems and issues with printing. So what you could do is, if you have something that you want to scan, you just print screen it. I use the Windows key Shift and S to just highlight something and snippet something from the screen, and then you can just put it straight into Paint 3D. And once you do that, you can then start to use the brushes and then print screen that, pop it into a Google Pictures document on the Google Classroom, and then upload that work. So that should save you from using up all your printer's ink. Right. Okay. So I'm going to use blue for the calciums. And I'm just going to select my brush over here. So the way that I see this is I see this calcium as being one particle on the reactant side. The reactant side is the left-hand side. The product side is the right-hand. The reactant side is the left-hand side. The product side is the right-hand side. And I just see this as being one particle of calcium on the left-hand side that we start off with. So we're going to use that for a start. So that's your calcium. That's why that's there. Okay. Then I'm going to use this brown color for carbon. Okay. So the carbon's there. That's absolutely right. Okay. So what we're doing is we're effectively just seeing whether we actually have the right number of each of the particles. Now this was the error. Okay. So the oxygen, the error is only in the table. It should actually be 3. So there we go. There's your 3. Okay. So you got 1, 2, 3 of those on this side. And with if I just highlight this in white, this was what the question was that you, as you received it. The H was pick as lighter blue this time. So let's go for that. H is there, that's absolutely fine. Okay, and then the Cl, I'm going to go for a green color. Okay, so the Cl, that's just 1 on this side. So that's the way that I actually see this on the reactant side. Then you've got the arrow. So when you have a chemical reaction, what you do is you just basically have a rearrangement of the particles themselves. So I think what you end up with on the right hand side is 1 calcium. So I'm just going to select that. That's why on the table it has this. Okay, and just go through each of these again. And this might look very painstaking. Now this 2 over here means that you have 2 chlorines. Okay. So really, I should have explained that when you had the 3 over for the oxygen, that 3 means that you have 3 oxygen atoms in that molecule, okay? So the little 2 denotes that you have 2 chlorines. So with the carbons, let's just move on to the carbons. That's 1 atom in the molecule. And let's do the oxygens. Now there should actually be 2 here, okay, because there are 2 oxygen atoms in a carbon dioxide molecule, okay, so that was the other misprint that was there, but that was fine. You could still have done the question like that. Right, okay, I'm just going to make sure that I've got my oxygens there, and make sure I've got my carbon there. I need to put my 2 chlorines from earlier. There we go. You can already see now that you've got 1 chlorine on the left-hand side, 1 chlorine particle, and you've got 2 chlorine particles on the right-hand side. I should really say that this is a chlorine atom on this side, and then this is a chloride, it's a pair of chloride ions on the right-hand side. But just for the stoichiometry, you can just like forget momentarily whether it's an atom or whether it's an ion, and in the same way you can also forget whether it's a molecule or an ionically bonded compound. You don't have to worry about the bonding of whatever, or the nature of the particles, whether it's an atom or whether it's an ion. You don't have to worry about that when you're balancing chemical equations. All you need to worry about is, can you actually add up stuff? So all right, okay, we've just spotted that the oxygen is also present in the water. So I'm going to add another oxygen there. Okay, so, I didn't like that one, so I'm going to just undo that. There we go. Can't stand it with smudged out atoms. And then the hydrogen was that lovely light blue color. So this 2 over here means that you have 2 hydrogen particles, I should say. Okay, so I'm just going to refer to them as particles, all right? Otherwise you're going to find it too confusing. Okay, all right, there we go. Okay, that's 1, and that's 2. Right, okay, so this is why I like to consider this as as an approach as a bit like M&M. So I always called it M&M's approach in class. So you can actually see, I'm just going to make sure that this is accurate as well. So when I see this calcium carbonate rather, I see that. Hydrogen chloride, that's that. CaCl2, I'm just going to add an extra green there just to help you guys along, because you may not be super confident with it yet. Okay, so that's basically what I see. Now, what you can see straight away are 2 things. You can you can see that let me just go through this. You can see that you've actually got 1 less hydrogen on the left-hand side than on the right-hand side, okay? And the same thing with chlorine. So this is actually quite a good example for you to start it off with. Okay, the rest of them seem to be balanced. You have 3 oxygens on the left, 3 oxygens on the right. You have 1 calcium on the left, 1 calcium on the right, 1 carbon on the left, 1 carbon on the right. So what you cannot do, you cannot change the small numbers, all right? You cannot, if you change the small numbers, if you like, say for example, say, oh, I've got 2 hydrogens on this side, so on the left hand side I'm going to change that to 2, and I'm going to change that to 2. So can you just sign me off? That's not going to work, okay? And the reason why is because you actually cannot change the formulas. If you change the formulas, you're actually making a completely different chemical itself, and that's just not right. So what you can do is you can add numbers. Okay, so like I want to multiply everything there. Okay, now I want to multiply it all by 2. So the rules are that we can stick a 2 in there, and if that was the case, if we did that, then we would have to multiply everything on the left hand side. Sorry, everything on everything after the 2 by 2. Okay, so 2 times 1 is 2 for the hydrogen, and 2 times 1 is 2 for the chlorine. I hope that's clear. I was just struggling with the watercolors there. Right, okay, so now what you can do is you can actually if you want to think about it, using the skills approach that I had. And now we've got 5, 6, 7, 8, 9, 5, 6, 7, 8, 9, and we've got 2 blue, 2 green, 2 blue, 2 green, 1 dark blue, 1 orange, and 3 orange. So the answer to this question was stick a 2 in front of there. Okay, right. I hope that, so you can pause it, you can rewind the video, and I would strongly suggest that when you do this type of question, get your felt tips out, make it colourful, make it interesting. If you haven't printed this out, then just use Paint 3D. It's really, really easy, it's simple. Loads of you have been trained up on how to use this through your ICT exams. Okay, so get used to it, get colouring in, and then what you could do is if you do it like this, right, and you print screen that and you submit that as part of your scans, I can then have a look at it, and if I'm sort of in doubt as to where your numbers are as you've typed them in the Google quiz, which I did do when I was reviewing all of your work, then I can look at these scans and I can say, oh yeah, right, so you put a 2 in the Google quiz and you put another 2 in the Google quiz, but your scans are actually okay. And even if your answers in the Google quiz are not right, or you made a mistake and you copied it over from another question, I'll look at your scans. So it's really, really vital for you to do that. There were a couple of people who did not put the scans in and they put the right numbers in. I had to say, sorry, I can't give you the credit for it. And it's exactly what the exam boards do as well. If they see that you've got an answer in there sometimes, they won't give you credit if you haven't got the working out, particularly in physics. But the good news is that for stoichiometry, when it comes to an exam situation, all you need to do is you need to put the numbers in. But right now, we're not in an exam situation, we're in a teaching and learning situation. And I really, really do want to make sure that you've got the understanding there. I want to make sure that you haven't just Googled the answer and plugged it in there and signed it off, all right? Okay, so ran over, apologise for that. Let's have a look. So I'm going to start a new one. I think I'm actually going to save that as well. So I'll save that as example 1 story, and what I will do is I'm going to upload this onto our stoichiometry. I'm going to upload this onto our Google Classroom. All right, okay. So what I'm now going to do, I've got I'm going to load up another video now. So watch the second video, and the second video will just go through each of the other 4 examples very, very quickly. Okay.